Hi, in today's webinar we'll be discussing about formulation of linear programming problems. I hope you watched my previous webinar wherein I discussed about the basics of linear programming. If not, please press the bell icon to watch the same. Okay, so how do you formulate a linear programming problem? Now, the major steps in formulation of linear programming is the first step is to define the objective, whether it is to maximize or to minimize. Now, basically, the problems used to be about maximizing the profit, or it used to be about minimizing the cost. The next one is to define the decision variables. You have to identify the decision variables and then have to define them very clearly. The third step is to write the mathematical function for the objective. Then you have to identify the constraints and write them down. And that is, you have to tabulate them and put them into a proper order. These are the different steps in the formulation of linear programming problem. Now, let us look into a very basic and simple problem. We have two products, chairs and tables. Now, the decision is to be made like how many of each is to be made in a month. How many of chairs and tables are to be made in a month. The major objective is only one, is to maximize the profit. Okay. Now, you are given some attributes in this data. Let's check them one by one. We are given like the profit contribution is ₹7 for tables per table, and for chair it is ₹5 per chair. Now, if you look into the carpentry work, it takes 3 hours to complete the carpentry work for one table, and it takes 4 hours to do the carpentry work for one chair. Now, the biggest constraint problem here is you will get the carpenter only for 2,400 hours. Okay, now going to the next one. Here in the painting thing, what happens is you take 2 hours to paint a table, but you take only 1 hour to paint a chair. Again, the biggest constraint is you will get the painter only for 1,000 hours. Okay, now some more limitations are there. Now that limitation is like you cannot make more than 450 chairs, and you should make at least 100 tables. So within these constraints, you have to formulate a problem. So we'll try to look into the solutions. Now the first step in solution is to identify the decision variables. Now, what are the decision variables? We understand that the basic major decision variable here is you have two products, and you have to understand, you have to take a decision of how many of each to be made in this month. Okay, so here the decision variables are the number of tables and number of chairs that is to be made. So let T be the number of tables to be made. I arbitrarily took T. I simply took T because T stands for tables. You can take any digit, any alphabet as you like. The next thing is you are supposed to choose for chairs. So I have taken C for chairs. So I have defined like capital C is the number of chairs to be made. Now with this, I'm framing the objective function. Objective function is to maximize the chairs and tables. Now, how many chairs and tables are there? Now look here, you have ₹7 per table and you have ₹5 per chair. So this is the major constraint. So with this, you can make like 7T plus 5C. You have to maximize 7T plus 5C. How did you get it? You have to maximize the profit. See, that is what is being given here. You are supposed to maximize the profit. Now, what is the profit contribution? Is 7 and 5. That is how we got this. It is maximize 7T plus 5C. I hope you got it. Now, what are the other constraints? Now, the constraint that is given here is you have 2,400 man hours, and you have 3 hours and 4 hours for chairs and tables. So we'll write the first constraint. You have 2400 hours of carpentry time available. Now 3t plus 4c is less than 2400. How did you get this 3t plus 4c? It is from here. 3t plus 4c. 3t, t is the table, 4 chairs is less than 2400. Now why is it said less than 2400? Because you have only 2400 hours of carpentry time available, only 2400. Now you have only 1000 hours of painting time available. So we'll just check how you got 2t plus 1c is less than 1000. Now check once again here. 2t plus 1c is less than 1000. Okay, makes sense. Now here again it's 2t plus 1c is less than 1000 hours. So I hope you understood this particular table here. These are the first constraints, but again you have constraints. What are those constraints? You cannot make more than 450 chairs. You cannot make more than 450 chairs. So chairs is less than 450. And you should make at least 100 tables. So tables is greater than. Now these symbols are important. Now it is not more than 350. So it should be lesser than or equal to 450. So 450. And you should make at least 100 tables. So tables is greater than 100. Now at the same time, there is one more constraint which was not said there, but we are supposed to identify that. And that particular constraint is you cannot make a negative number of chairs. You cannot make negative 1 chair. How can you make a negative 1 chair? You cannot. So t is greater than or equal to 0 and c is also greater than 0, which means these are integers or whole numbers greater than 1. Okay, so makes sense. Now we'll just write everything in a orderly fashion, as this is how we write a model. So model could be written like, you have the objective is to maximize 7t plus 5c. Now you can even, as you progress, I'll tell you, like you have to write maximize z is equal to 7t plus 5c, thereby making it an equation. Put an equal symbol like, and you will put maximize z is equal to 7t plus 5c. Z is actually the decision variable that you have to say. Then you have the subject to the constraints. What are the subject to constraints? 3t plus 4c is lesser than or equal to 2400. 2t plus 1c is lesser than 1000. C is less than 450. T is greater than 100. Where t and c is greater than 0, they are not negative numbers. So we just put all the objective function as well as the constraints in one particular page. So this is how you write a model. Now this particular slide gives you general formulation of LPP. I just want you to check this. Maybe if, in your math classes you would have understood all these things, but don't try to crack your head. If you just try to give an idea as how it looks like. You have a maximization or minimization objective function, subject to the constraints, and you write what is x, b, c, j and all those things. So that's it. Okay, so we will just go to one more practice questions. Now this is a little more simpler one. You have Maruti. So this is actually a marketing thing. So Maruti is manufacturing 2 cars, Wagoner and Alto. The manufacturing time required to make them, the profit and the capacity available at each work center is given below. Now we look at the table. You have 2 things, Wagoner and Alto. Now Wagoner takes 1 hour to paint and 5 hours to align, 3 hours to assembly. The profit per unit is 80 rupees. Alto takes 2 hours for painting, 4 hours for aligning, 1 hour for assembly, and the profit is 100 rupees per unit. For 1 car, you get 80 rupees and 100 rupees as profit. Now total capacity for painting is 720 hours. So maximum you can paint for 720 hours. You can do alignment for 1800 hours and assembly only for 900 hours. So within these constraints and with the given objectives, Objective is to maximize the profit. Okay, so we'll look at the solution. The decision variables here is, you are supposed to find out the maximization for Wagoner and Alto. So I'm using the variables as W and A. W stands for number of Wagoners to be made, and A stands for number of Alto to be made. Now, in the previous question, we understood that it is basically speaking about maximizing the profit. Now, what is the maximization that is to be done? You are maximizing 80W plus 100A. How did you get 80W plus 100A? Now, 80 is the profit that you get for Wagoner and 100 is the profit that you get for Alto. That is how you got 80 and 100. So maximize Z is equal to 80 Wagoner plus 100 Alto. So that is the objective function. It's a maximization problem. And what are the constraints that is available? The first constraint is, you have 720 hours of painting time available. Now 1W plus 2A is less than 720. Now how did we get it? 1W plus 2A is less than 720. Now similarly, now we'll just go there and check if it is right. 1W plus 2A is less than 720. Now you have 1800 hours of aligning time available. Now if you go back, you can understand it's 5W plus 4A is less than 1800 hours. 5W plus 4A Alto is less than 1800. Now what is less than? Because you cannot take more than 1800 hours. You're given with only 1800 hours. Now the next one would be like, for assembly you will take 3W plus 1A is less than or equal to 900 hours. Now without even looking, we can formulate. Now 3W plus 1A less than 900 hours. Now there are no negative constraints, because you cannot make a negative number of cars, Alto and Wagoner. I hope that you can understand that. Now, so just put them in order. Now, what is the solution? Now, the final solution is, you have the decision variable as W and A, the number of Wagoner and Alto to be made. Objective function is to maximize. You have Z is equal to 80W plus 100A. You're just making it an equation. And you have the constraints given here. This is the solution. Just putting this into a very one page and give a proper bordering and all, that is the solution. So I hope you are understanding as how to formulate a linear programming problem. Now there are a lot of problems out there. I'm putting two more practice questions in the screen. Put a pause on them and try to solve on your own. These are very simple marketing areas, and problem 4 is also there. You can just take a minute, pause the video and try to find the solutions. Thank you very much. Thanks for watching.